Alright guys, we're going to be solving on the question from the second chapter of the Mechanics of Materials by Johnston, question 24. And in this one we have a steel frame which has elastic modulus of 200 gigapascal that has a diagonal brace BD with an area of 1920 millimeters squared. And we need to determine the largest allowable load P if the change in length of member BD is not to exceed 1.6 millimeters. So the formula that we have for the deformation, as we talked about, so we were talking about the member BD, since we have the area and also the length. So our formula would be FBD times the length of BD over the elastic modulus times the area. So we have the change in the length, which is 1.6. So basically we have the deformation 1.6 millimeter. We can just multiply this by 10 to the minus 3 to get it in meter. And we should be able to find the forcing member BD here, which is basically, we just have to cross multiply these. So we're going to have the deformation 1.6 times 10 to the minus 3 times the elastic modulus 200 gigapascal. So 200 times 10 to the 9. And the area would be 1920 millimeters squared. We're going to multiply it by 10 to the minus 6 in order to get it in meters squared. And here we need the length of the BD, which is not that hard to find. We have a right triangle in here. And we basically are looking for the hypotenuse, which based on the Pythagorean theorem would be the square root of 6 squared plus 5 squared. So let's just calculate that and put it in the denominator. So the square root of 6 squared plus 5 squared, that's going to be 7.81. So now we can find the forcing member BD. Let's see what we get. So these will be cancel out all of them. So basically we're going to have 1.6 times 200 times 1920 over 7.81. So that's going to be 78.67 times 10 to the 3 newtons. And now we have the forcing member BD. What the question is asking is the load P that we are applying in here. If you look at the joint C, and if we just draw the free body diagram for joint C, we have P, we're going to have a forcing member BC, and we're going to have one force in here, FCD. And what we are interested in here is the force BC, because that way we can move on to the joint B after this. And as long as we have FBC, we should be able to figure out the P in here. So for finding the P, if we just do sum of all forces in, again, this is the joint C, in X equals 0, this will be our positive for X. Basically, our FBC is equal to P. So if that's the case, and that's the correct direction for FBC, because it has to be in the opposite direction of P. So now that if we go to the free body diagram of joint B, since the member BC in here would be in compression, the force that is applying to this would be in this direction, FBC, which is basically the force P. So I'm just going to put P in here. And we're going to have two more forces in here. This will be our FBD. And I'm going to take this direction because that's the only force that has X component. So it has to be to the right in order to cancel out our P in here. So we just have to get some information about this angle. And if we just, again, do sum of all forces in X equals 0, we have FBD, we found it from the previous step. We should be able to find the force P. So we basically need this angle here. We just call it alpha. Cosine of alpha would be our X component, which would be this side over the hypotenuse, or 5 over what we found for hypotenuse 7.81. So we have FBD cosine of alpha 5 over 7.81 minus P equals 0. And that's how we can find the force P. So basically we're just going to multiply this by 5 and divide it by 7.81. And that's what we're going to get, 50.36 times 10 to the 3 newtons. 450.36 kilonewton. And the final answer for this question. Hope everything was clear. Let me know if you guys have any questions. You guys take care. I'll see you in the next one.